In this lesson, we will write a logarithmic expression as a single logarithm. So we're still going to use those same properties that we had before, but now we're going to go backwards. So would be considered expanded form, and if they asked you to condense it, that is what you would be doing. And so what I'm going to do first is notice that both of my logarithms have a common base. If they don't have a common base, I can't really do anything with them. So I'm going to write this as a single logarithm. Notice this is subtraction, so I know that that's going to end up being a quotient. The first thing I want to do, though, is get rid of this 3. I want to move that to become an exponent. So I'm actually going to do this all in one step, and I'll try to talk through it as slowly as possible. So I know that it's going to be log base 4, because both are log base 4. The numerator is going to be 2x plus 7. Again, notice that wasn't expanded out. It was the log of that entire expression. The minus says the rest of this is going to go on the bottom of the fraction. And so then the minus, it would be minus x to the third. So instead of 3x, the 3 becomes the x, 3 becomes the exponent. So now notice the log base 4 and the log base 4 is just out at the beginning because we want a single logarithm. This is my numerator, and then this is my denominator, and we replaced that 3 as the constant as the 3 of an exponent. So this would be my single logarithm. Let's look at the second one. Same idea. These are log base 10. Both are the same. Again, this 3 is going to be an exponent. It's going to be the exponent on both x and y. This is a product, however, because it's plus. So when I write this as a single logarithm, I'm taking the log of 2 times xy cubed. Again, the 3 became the exponent, and I don't like the way that looks, so I'm actually going to simplify it further. This cubed tells me that I have a log of 2 and then x to the third y to the third. So it's the log of all of that. So the 2 came from here. We knew it was a product because it was plus. The 3 became the exponent that we distributed to both the x and the y because they were being multiplied. And then I wrote it as one single logarithm. This question is a little bit longer, a little bit more complicated, but let's take a look. This one, notice that I do have a value here that is being distributed. So let's do that first, because in general, we don't want to have values inside parentheses if we can help it. So that gives me negative 2 natural log of x plus 2 natural log of x squared plus, I'll simplify this later, 2/3 natural log of z cubed minus natural log of z. Again, my goal is to write this as a single logarithm, but before I try to do that, I want to simplify whatever I can. So I'm going to take anything that's a constant and turn it into an exponent. Leave the negative out front, so I have negative natural log of x squared plus natural log. Now this is already x squared, but I have to multiply that by the 2. So this is natural log of x to the 4th. This, again, 2/3 times 3 would actually give me a 2, because we take 2 times 3, which is 6, divide by 3, which is 2. So natural log of z squared, and then minus the natural log of z. Now that I have it a little bit more simplified, I'm going to write it as a single logarithm and then reduce any more if necessary. Anything that has a minus, we know that tells us it goes on the denominator. Anything that has a plus goes on the numerator. So my single logarithm would be the natural log. In the denominator, I have x squared. In the numerator, I have x to the 4th. In the numerator, I have z squared. And in the denominator, I have z to the 1st. Obviously, I can simplify this a little bit more. This 4 and this 2 reduce to x squared, which of course would remain on the top. Z to the 2nd and z to the 1st would reduce to z to the 1st on the top. So I really just have the natural log of x squared z. That's my final answer. So everything that was in the denominator ended up canceling out. Here's a similar one for you to try, so press pause, try this question completely, and then press play to check your work. So for the first thing I would do, of course, is to turn this 1/3 into an exponent. So this is log of t to the 1/3. Again, that base is 10. All bases here are 10. I have plus log of t squared minus 9, which I didn't have to do anything to, and minus log of t minus 3, which I didn't have to do anything to. Now that I've done that, I can go ahead and write this as a single log, but I will have to do more simplification. So I have log base 10. This is positive, which means it goes on the top. So on the top, I have t to the 1/3. Also on the top, because it's plus, I have t squared minus 9. And on the bottom, I have t minus 3 because of the minus. Now, it appears that t squared minus 9 can be factored into t plus 3, t minus 3. So that's just normal quadratic factoring. Of course, we have a t minus 3 on top and on bottom that will cancel. So that gives me log. On the top, I have t to the 1/3. If you want to write that as the cubed root of t, you may. And then t plus 3. Everything else has canceled. Now, if they want me to, it kind of depends on what Alex is asking for, but it's possible that we would want to then distribute the t. In general, I would think that this is the most simplified version of the solution, but if they want it without parentheses, then I would multiply that. I would have t to the 4/3 plus 3t to the 1/3. There are other ways to simplify it as well. I would probably leave it just like this. Okay, if they wanted a single radical, you could write it in that way as well, but we'll just stick with this for now.